two more rules of differentiation that we are going to cover. This now goes to 9.5. More differentiation rule. One has to do with the product rule. So if your function is composed of two functions multiplied by each other, how do you get the derivative of that? Okay, how do you get the derivative of that? So here it looks very complicated, but it's basically like this. If y, again, you write as is a function of x and is equal to 3h squared plus 16 times 15h to the third, 15h to the third plus 12h minus 8, product of two functions. How do we get the derivative of this? According to the formula, y prime, which is f prime of x, would be equal to derivative of the first function, derivative of this one. What's the derivative of this one? It is 6x. Derivative of 16 is 0, so I don't need to write it. Derivative of the first one multiplied by the second one, by the whole of the second one, 15x to the third plus 12x, plus 12x minus 8. That's 1. Plus derivative of the second one times the first one. Derivative of this one would be what? 45h squared plus 12 times 3h squared plus 16. Now you multiply everything together, then y prime would be equal to 6x times 15h to the third. It would be 90h to the fourth plus 6 times 12, 72. X times x is h squared minus 6 times 8, 48h. Now multiply these together, plus 45h squared times 3h squared would be 135 h to the fourth plus 45 times 16, 720h to the second. 12 times 3h squared is 36h squared. 12 times 16, right? That is 160 plus 32, that's 192. Therefore, y prime would be equal to 90h to the fourth here, 135h to the fourth. It would be what? 225h to the fourth. 72h to the second. 72h to the second. 36h to the second. That is 108. 108 and 720 is 828h squared. Take care of all of these. Plus 48, minus this one, minus 48h, and plus 192. It was a little time consuming, but that's basically all it is. So it is simply derivative of the first function, which is this, multiplied by the whole of the second function. Then derivative of the second function, which is this, multiplied by the whole first function, added together. That's it. That's how you get a product rule. Two functions multiplied by each other. Now, I'm sure, or hopefully, they will have something a little bit less complicated than we just did because I just made up those numbers and those functions. So here it gives you an example. F of h is equal to, one function is h to the third plus 2h plus 5. The other function is 3h to the seventh minus 8h to the second plus 1. So these two are multiplied by each other. Again, that's what the product rule is. Two functions multiplied by each other. These two functions are multiplying by each other, right? So you get f prime, derivative of the first one, derivative of this, which is this, 3x to the second plus 2, multiply by the whole of the second one, the whole of the second one, then plus derivative of the second one, derivative of second one, which is here, 21h to the 6th minus 16x, derivative of the second one multiplied by the first one, or the first one multiplied by the derivative of the second one. When you go and simplify this, here derivative of the first, derivative of the second, and those are the actual functions, the rest of it. You keep going and simplifying, it comes up with this, right? You can go ahead and multiply yourself to see whether they did this correct or not. Hopefully they did. That's the product rule. Another differentiation rule is called the quotient rule. So when you have two functions divided by each other, how do you take the derivative of that? How do you take the derivative of that? Okay? So again, let me write it in layman's term if you want. Y is equal to some function f of x divided by some function g of x, right? Instead of this, maybe this is easier to see. Y is equal to f of x divided by g of x. How do you calculate the y prime? Is equal to derivative of the numerator, which is f prime of x, times the denominator, times g of x, minus derivative of denominator, which is g prime of x, times the numerator, which is f of x, times f of x, divided by g of x squared. I hope this is a little bit easier than what you have up here. So that's all it's saying. Derivative of the numerator times the denominator minus derivative of denominator times the numerator divided by denominator squared. This numerator, denominator squared. So this might be a little bit easier formula to handle as far as quotient rule is concerned. Sometimes remember the high, low, I don't like it either. But you might have seen this if you have taken this calculus in high school. You might remember it like that. So the quotient rule, a function, numerator is 3x plus 5, denominator is h squared minus 2. Again, to find the derivative, f prime of x, that would be equal to a long division line. Derivative of the numerator, derivative of 3x plus 5 is 3. Multiplied by the denominator, that is h squared minus 2. That's 1. Minus derivative of the denominator, derivative, I don't need parentheses here. Minus derivative of the denominator, derivative of h squared is 2x, and derivative of minus 2 is 0. So this would be 2x multiplied by the numerator, which is 3x plus 5, divided by denominator squared, that is h squared minus 2 squared. Therefore, f prime of x is equal to 3h squared minus 6 minus 2h times 3h, that is 6h squared, plus 2 minus 2h times 5 is 10h. I'm sorry, that should be minus 10h divided by h squared. You don't need to do anything that in most cases. H squared minus 2 squared. Now f prime of x, therefore equal, now 3h squared minus 6h is minus 3h squared, and minus 6 and minus 10 is minus 16h divided by h squared minus 2 squared, right? I can factor out if, well, there's nothing. The only thing I can factor out is a negative. The only thing I can factor out is a negative, and negative can be in front. So it would be 3h squared plus 16h divided by h squared minus 2 squared. So that's for the quotient. Seeing what they did on the slide. Again, f prime of h, 3 times h squared minus 2. 3 is the derivative of the numerator, and that's the whole of the denominator, minus 2h, which is the derivative of denominator, times 3h plus 5 divided by h squared minus 2. Derivative of numerator 3, derivative of denominator minus 2h, and you simplify. Did I miss something? I think I made a mistake in my calculation. Let me go back. Seem to have a, oh, it doesn't show. It doesn't show what I did. I think in my calculation I made a mistake somewhere in there. So minus 3h squared minus 10h, because I didn't have any minus 10h here. I did something wrong there. Yeah, that was minus 10h. I think I just put minus 10. Yeah, I put minus 10, that's why I came with minus 16. So what I did was wrong. And finally, the higher derivatives, the second derivative, third, fourth, and as far as you can do all the way until the derivative comes out to be 0. The second derivative is shown with double prime, triple prime, quadruple prime, and so on and so forth. That's what the derivative is. So for example, if y is equal to 5h to the fourth, then y prime would be equal to 4 times 5 is 20h to the third. Then y double prime would be derivative of y prime, which would be 60h to the second. Y triple prime would be 2 times 60, that's triple prime, 120h, and y4, right, would be equal to 120, and y5 would be equal to 0. That's it. We cannot go any further than that, right? So that's first, second, third, fourth, fifth derivative of a function. You can go until you get to 0, right? Example of higher derivative, given that f of x is equal to 3h to the fifth minus 2h to the third plus 14, find f triple prime of x. Again, you find f prime of x. 5 times 3 is 15. H to the 4 minus 6 h to the second. Of course, derivative of 14 is 0. Now, f double prime of x would be equal to 4 times 15 is 60. h to the third minus 12x, that's double prime, triple prime of x would be equal to 180 h squared minus 12. That's it. Again, f prime 15h to the fourth minus 6h squared, double prime 4 times 15, 60, h to the third 12h, triple prime 3 times 60, 180, h to the second minus 12. That's a triple prime, right? Or the third derivative of the function. Examples finding higher derivatives. Here is a quotient. We have find f double prime of 2. So first f prime of x, that's the first derivative, right? First derivative. So here the derivative of the numerator is 2. Derivative of the numerator is 2 multiplied by the denominator. That's what this is. And derivative of denominator is 3 multiplied by the numerator. You subtract that. Divided by the denominator squared. Denominator squared. That would be equal to, now if you simplify this, 2 times 3x is 6x minus 4. And here would be minus 6x and minus 1 times 3. That would be minus 3. So minus 6x and plus 6x would cancel. Minus 4 and minus 3 would be minus 7. And 3x minus 2 to the second power. We can bring this one from the denominator up to the numerator, so get rid of this quotient and write this with the negative power. So it would be minus 7 multiplied by this same thing with the negative power. So negative 2 would be the power here. Everything else remains the same, right? So now, to get the derivative of this, this is a multiplication, right? This is a multiplication. So if you want to get the derivative f double prime of x, right, that would be the derivative of 7. This is multiplied. This one multiplied by this. Derivative of 7, which is 0, multiplied by 3x minus 2 to the minus 2. That take it as 7. Plus derivative of this. Derivative of this. What is the derivative of this? That would be minus 2. And put a bracket here. That would be better. Bracket minus 2 times 3x minus 2, subtract 1 from the power, so it would be minus 3, multiplied by the derivative of what you have in parentheses, so multiplied by a 3. That is the derivative of this, multiplied by minus 7. So f double prime of x would be equal to, well, this is 0. This is 0. Let me simplify the brackets first. Minus 2 times 3 is minus 6 times 3x minus 2 to the minus 3 power, right? Well, times 7, or times minus 7. So minus 7 times 6, it is 42. 42 times this whole bracket, or parentheses actually, I multiplied by the bracket already. So it would be 3x minus 2 to the minus 3 power. Now I can bring it back to the denominator, so it would be 42 divided by 3x minus 2 to the third. Now if I want to evaluate this at 2, that's what it says. Evaluate this at 2. every place I see an x, which is only right here, I plug in 2. So it would be 42 divided by 3 times 2 minus 2, the whole thing to the third power. That would be 42 divided by 3 times 2 is 6. 6 minus 2 is 4. And 4 to the third power is 4 times 4 is 16. 16 times 4 is 64. Right? So that's the answer. Let's see what we got. First derivative, so second derivative should be here. And the final answer, by the way, 42 divided by 64. This is the second derivative itself before substituting 2 for it. There it is, 42 divided by 3x minus 2 to the third power. So this is correct. You substitute 3 times 2, 42 divided by 4 to the third. 4 to the third is 32. I don't think so, huh? Oh, they simplified. It became the simplified by 2. So divide everything by 2. So divide by 2 would be 21, and this one would be 32. Yeah, that's correct. That's the higher derivative and substituted number. We're going to stop here. This goes to the next section, which is 9.6, which we are not going to cover. That's the end. Again, now you know that there are other resources, including the videos I made on exercises and the review exercises, plus the videos that come on WebAssign with the book itself. So you have a lot of resources to use to be successful in this class. Thank you for watching and have a good semester.